So today's topic is continuous assignment in Verilog. So continuous assignment, as its name suggests, is continuously running, means continuously assignment is going on like RHS and LHS. So RHS is continuously assigned to our LHS. So this is the meaning of continuous assignment, and it is also a block similar to your initial and always block. So continuous assignment is used only for nets, wire types, and represent combination logic. We will come this point after this slide. It continuously drives the value onto the net wherever any RHS value changes. So this is a simple syntax. Here expression is continuously assigned to our net type. For example, here variable y is there, here variable a is there, so a continuously assigned to our y. So the previous point is this continuous assignment is only for net types, is because if net type, for example, if it is a signal and this expression does not run on clock triggering, so it will assign here. So continuously assignment is going on. So if you use range here, in this means our storing data type, so what will happen, it cannot store, it will overwrite the same value. So some memory is there, here first a1 is coming, then after 2 is coming, then after 3 is coming. So this is not possible, it will give a compilation error for this kind of thing. So here it is important to use only wire types, for example net types. So net types, any net types is okay with our assign block. So this is the main thing in this type of assignment. In procedure assignment, in LHS and there is RHS, right? So in our procedure assignment, for example, inside your initial or always block, this should be range because something we need to store. And in this assignment, in assign block, here LHS should be a net type because the continuous assignment is going on here. So continuously it is running. Continuous assignment is going, so wire type is needed because current flow continuously inside something, right? So similar thing. So the key things you have to remember while writing your assign block is used with wire and other net types, not range. So this I have already clear. And one thing is that here A and B can be range or wire, that is fine, but the condition is LHS should be always a net type. Simulates gate level or combinational circuit. So you can create this type of circuits here, and both this gate level and combination circuits, like gate level modeling and combination types of modeling, I will explain this part in coming videos. And combination hardware is like you can create multiplexer and anything with that. Okay, now RHS is evaluated continuously. As I said earlier, it is continuously assigning. So here our RHS is continuously assigning to our LHS. Multiple assigns driving a same wire represents wired logic resolved using strength rules. So I have created a short video for resolve strength, but in coming videos I will also explain the strength. So here the point is like if there is multiple wire like A, B, and it is continuously assigning to a single wire, that is wire. So the output is dependent on the strength of A or B. So for example, if I will say there is some pull type of strength, pull 1 and strong 0, and similar here is our strong 1, and so if the 1 will come, so strong, its strength is more, so here 1 will evaluate, either here it will be 0 or 1, it doesn't care because this is our strong 1. So something similar topic is there, but main thing is that depending on the strength value, the wire output will be there if multiple inputs are there for a wire assign statement. So this is the most famous concept of our assignment, and you will see in industry using conditional assignment with the help of our assign block, continuous assignment block. So conditional assignment, also called ternary operator. Yes, this question mark and this syntax you can see, this part is called ternary operator, and ternary operator is this question mark and this colon, and inside continuous assignment for combinational reasoning. So you will write combinational logic for that. Okay, now I will explain what is our ternary operator. So this is variable output, and here you can write our condition a comma b. So if this condition is true, then your a will be the output. If this condition is false, your b will be the output. A is equal to 1 and b is equal to 2. So here a is not greater than b, so the output will be 2. If here a is 3, then output will be 3. So this is our ternary operator, and you can use nested ternary operator. For example, you can give another condition in the place of a in the place of b, because if it is true, then the value will be a. If not, then you can give another condition in b, then continuously you can pull that off. Like one c a, or again one condition, then you can write a, then again one condition, and you can end wherever you want, like 0 if the end. So you can use it like a nested if else type of thing. Next is our loop in Verilog.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So loops is common thing in every language, but here is some extra loops and some other concepts. So first we will see loops in. So here it is, loops in Verilog are used to repeat a group statements, and they are mainly used inside the processor block, like always and means. So this is the different thing as respect to our C language or any other language. So here always an initial block is must for using the loops. So initial block and always blocks are intelligent, so you can use there. You can create RTL structure for that. You can create behavior modeling with the help of use. You can initialize address. For example, if you are using ABB protocol, here A1 is block A, one is block B, or you can say one CP A, one IP A, or one IP B. Your communication is there. So in address block, you can assign address with the help of loops. Generate loops for hardware application. So I have created a separate video for this, so I haven't included in this video. So this is a hardware perspective thing, but these loops are our hardware plus our test bench perspective. Now, so important rule you must remember when writing the loops are loops do not run during simulation like C. So in simulation, like you have created some any code with the help of C, it will run continuously in compilation, before compilation, and every means the code will run compile. It will like one by one it will compile and it will give your answer. But in hardware it is not like that. There are some phases for compilation, simulation, extraction, these phases. So these loops are not running in that simulation phase, it will run on compilation and extraction phase. So this is what this statement is saying here. And as previously I have said, initial and always block will be there, and loops do not create sequential hardware. They unroll at all compile time. So there is one compile time. I will write compile, then there is extraction phase, and then there is simulation phase. So this process is going on inside your compiler, or you can say your software. So this compilation phase, this and extraction phase, you can say these things are going on, and some may create hardware but some may not. All this is for general loop statement rule, and loops do not create flops unless explicitly written inside the blocked always block. So you have to write the code as per you want your hardware. So this is the thing you should remember in writing any Verilog line or any statement or any code. So first is our most famous is for loop, which is mostly used. So simple syntax, initialization, condition, and increment. So this is the same thing, but in Verilog you have to write I equal to I plus 1. It is not like I plus plus. I plus plus is not there in Verilog, but nowadays compiler are mostly based on system Verilog, so you can use this I plus plus in, and it will run in every you say every software, you can say. But if it will give error, then write I plus I equal to I plus 1. So this is also correct, same thing, but some compiler may give error. And your logic statement. So here is one example integer I have declared by I, and there is one vector This is the array. We will come to this in further videos. So here this is memory, and I have created packed array, unpacked array. There is hybrid memory, hybrid array. So you can watch that video as well. So now initial begin for I equal to 0, you will start a loop until 256 and I equal to I plus 1. So you can write I plus plus, but the most compiler for Verilog, if you create .v file, then it will give error for I plus plus. If you create .sv file, then it will not give you error. So extension also matters. So this is how you write your for loop. Now our while loop. While loop is a simple loop, you can say, but the conditions for while loop you should remember is execute as long as condition is true. So I will give an example for that after this explanation. And be careful, can cause infinite loops in simulation. So yes, this and this are related. I will give example for that. You will understand better in that way, and generally not recommended in synthesizable hardware. So as I said, for loop and different loops are there for creating hardware, but it is used mostly in our test bench, and that also we use other loops than our while loop. So if you write here 1, for example, if you write here 1, so inside there may be any statement, it will be always true because while is 1, while 1, so it is always true. So these two statements will be there, like execute as long as condition is true. So it will be executing as long as condition are true, and it will execute infinite loop in this case. So this thing you should remember, and rest of the thing is like while condition check and then execute and end. Simple thing. Now move to our next loop. Is our repeat. This is a loop which is included in Verilog, and one of my most favorite loops is like repeat loop, because simple, right? Repeat number of times it should repeat, and in begin end whatever logic is there it will repeat. See, it may be your favorite sometime. And here is our forever loop, mostly used in our test bench. Runs forever as its name suggests until disable is there and simulation ends. So when simulation ends in systemverilog and UVM, internally it called our simulation end or $finish. So at the time this loop is stopped. So you should be careful writing this forever loop. Initial begin forever, mostly used for generating clock because it should be forever, just forever. And if you are writing multiple statement, then for example it is forever, then write begin end. So you can write multiple statement here. Okay, so this is summary table for all the loops, and loops are our for, while, repeat, forever, and generate. I have already made other videos for generate block, so you can watch that. So rest of the loops we have seen. So forever loop is synthesizable. RTL and test bench we can use both. While loop is partially synthesizable, so better not use this. Use for, and test bench mostly we use for that. And repeat is not synthesizable because there is no hardware. It will be specific for a specific number of repeats, so it is used on test bench. And forever as well, I know that I have said earlier that hardware runs forever, but always block is there for running forever. This loop is not used and synthesizable part of thing. So for loop it is not synthesizable. Clock generation and test bench means mostly in test bench. Generate block is used for, it is a block actually, more than a loop, it is a one block, and it is used for creating a hardware. So thank you, and comment you for any other videos, any other topic, and I will make the video for that. Thank you.
Please Lord give me a sign, a sign.